The next speaker is Daniel Mann, who's working for TNO in the Netherlands. He works as senior scientist and as a part-time research fellow at Hasselt University. So he'll be introducing circular smart windows, upgrading all glass with smart heat management.
Yeah, thank you very much for the kind introduction. Today I will tell you about two developments that we're doing at TNO together with industrial partners. Our smart window technology together with our recycling concept to reuse glass. I will only make a very short introduction because you all know all these figures, but you know that we are facing two major transitions currently, the energy and the materials transition. And flat glass and window products actually play a big role here because of the high energy and materials consumption in the flat glass production, but also in the use phase of windows in buildings. If we want to contribute to these two transitions, we actually need to look at the life cycle of flat glass. And here an important aspect is that we don't have a linear life cycle, but that we're looking into a circular life cycle of flat glass, so that we can optimize our glass for recycling and reuse, but also that we look at the service life of the glass so that we have higher energy efficiency in our windows. First, if we're looking at recycling, so we are currently working on a strategy to reuse glass from old windows in new IGUs that we do together with a couple of partners in the Netherlands. And the first question that you need to ask is actually, how can we reuse end-of-life flat glass? And you all know that there is not just one type of glass or one type of window. There is single pane, double pane, triple pane. We have monolithic glass, we have laminated glass, we have coated glass. So all starts actually with the conscious decision-making tree. And we saw something similar this morning already, where you need to think about, okay, what kind of glass do I have? What can I recycle? Do I need to break the glass down into cullet, or can I reuse the glass actually? What do I do with monolithic glass? What do I do with coated glass? What do I do with laminated glass? So in our study, we started focusing on monolithic glass, but you know that there are also a lot of challenges for the other types of glass, but this is the starting point. And here, we are working together with Hemubo, which is a construction company in the Netherlands, and GSF Glass, who is a glass processor also in the Netherlands. And we started by harvesting windows from a couple of buildings in the Netherlands. So these were selected because they were in different locations. Some were located at the sea, some were located more in the land of the Netherlands. Some were a bit more high-rise, some were a bit more low-level. Because we wanted to have a collection of different types of glass from different types of buildings and different types of locations. And then these windows were brought back to GSF. They have the IG2 pieces. I think yesterday in the presentation from Hegla, it was mentioned that they actually were the first customer of Hegla to install the IG2 pieces. They cut open the glasses and then they delivered them to us to TNO. And what you see here, we did not want to have the nicest, cleanest glasses, but we actually wanted to see, okay, how dirty can the glass actually be that you get back from these sites? And here you see that actually it can be very dirty. Yeah? And then we started by first characterizing the glass. So we looked at what kind of pollutants and defects can you actually have on the glass. And it deviates a lot which side of the glass that you're looking at. So you have the inner glass pane where you can have, for example, paint residues. You can have the outer glass pane where you then have more pollutants from the outside. But there are also a lot of pollutants and defects which come from the harvesting of the glass and from the transportation of the glass. So there are also things which can be optimized to reduce the amount of pollutants and defects that you have from the harvested glass. But the next step for us was actually to see, okay, which of these pollutants and defects can we remove by cleaning the glass and by optimizing a cleaning procedure. And here we started just in our labs first with cleaning by hand, but then we went over to industrial washing machines, and here we collaborated with Riulzi in Italy to see what kind of washing techniques are out there in the industrial washing machines and how can we clean the glass properly. And this morning you saw something about edge trimming, because actually the sealant on the edges is very hard to remove. But in an industrial process, you would like to use as much of the glass as possible. So actually, you don't want to do the edge trimming. And this is also one of the strategies where we're developing together with Triolsi to see how can you actually properly polish the edges to remove the sealant. And in an optimized scenario, then get clean glass out of it. Not all the glass is clean, not everything you can remove. So especially scratches are difficult to remove. And there are possibilities with polishing via abrasive brushes to get rid of some small scratches, but deeper scratches you cannot get rid of. And what we also saw, especially for the outer glass pane, that you can have glass corrosion. So here are also things where you can think about, okay, next strategies for in a design for recycling concept, can I develop some coatings, for example, which prevent these kind of scratches and glass corrosion happening in the future to make glass more recyclable? Or can I develop something else? Yesterday we saw some heat treatment of glass to get rid of scratches, but there's also a question, can we design some coatings which can cover the scratches and retain the quality of the glass to make more glass for reuse? But in this project we started just with the clean glass that we had. And then obviously you can use the clean glass as a non-coated glass to make an IGU, which currently is also being done by GSF commercially. So they're selling 50% circular glass where they combine a non-coated reused glass with a coated new glass for new IGUs. But if you want to make that 100% circular, you also need to be able to apply a low-E coating on the old glass. And that is something that we did together with Pilkington. In Germany, in Gladbeck, where we brought some of the glass that we cleaned at TNO and at Triolsi. We brought that to Gladbeck, where the glass was then introduced into the sputtering machine from Pilkington, and where they applied their Optitherm S3 coating on the glass. Now you can think about, okay, there are different glass surfaces. You have the outer glass surface, the inner glass surface. You have the glass surfaces which were in contact with the inner part of the IGU. You have the tin side, you have the air side. Are there differences? Can all these sides be coated with a low-E coating? We also applied on some of the glass panes a barrier coating because we thought maybe we can refurbish the glass surface like that and make it easier to apply a low-E coating. The positive result here actually was that for all of these surfaces, we could apply the Optitherm S3 coating, and we had very good properties which are very in line with the reference Optitherm S3 coating on fresh glass. So these results were very good, which meant that then the coated glass panes were brought back to GSF to make new 100% circular IGUs out of that. And here actually, mid of May this year, it was then announced by Humubo on LinkedIn, the world premiere of the first 100% circular IGU, which was produced at GSF. And these windows we have currently installed in some test buildings in the Netherlands, and we are monitoring them to see their performance, but also their lifetime. So now I come to the second aspect, which is the service life of the window. And here, actually, what we have developed in the last years is a smart window technology to optimize the energy efficiency of windows in intermediate climates. And the technology that we have developed is a thermochromic material based on vanadium dioxide that can change its crystal structure at a specific temperature. And with that change in crystal structure, it also changes the optical properties of the coating and therefore the G value of the window. So the technology we have developed to be completely transparent and visible, and also to not tint when it changes the properties from the cold to the hot state. So it's a completely transparent window as with your regular IGUs, but it modifies the infrared transmission through the window, depending on if you're in summer or in winter, to have the optimum G value and the optimum energy efficiency for your building. And the thermochromic material, vanadium dioxide, is not a new material, so it already has been worked on for 30 or 40 years. But what was always the challenge is actually to get optimized properties with a combination of a high transparency together with a high solar modulation. So the solar modulation is the difference in total solar energy transmission between the cold and the hot state. And you want to have that as high as possible, which comes with a lot of functional material. But if you add so much functional material, then usually the overall transparency goes down. And that's something that we have optimized in the last years by especially focusing here on this part of the solar spectrum between 800 and 1400 nanometers. And you see this is the part where the largest part of the infrared transmission of the sun is. And by optimizing the modulation in that range, we can actually achieve a very high transparency together with a high solar modulation. The technology is solely focused on the interaction with sunlight, which means, in an IGU, you still need to have your insulating properties. And these insulating properties in the smart window, we actually get by combining the thermochromic coating with a low E coating. So this is actually, it's not only one coating, but it's a combination with the current low E coatings. And that's the second part why we are focusing on the range between 800 to 1400 nanometers, because you know that low E coatings largely cut off all the longer wavelength infrared light. So that is anyway not available for modulation. But with this smart combination, we can actually make smart windows which have a high transparency between 60 and 70%, and you can modulate the G value between 10 and 13% between the cold and hot state, depending on what kind of coating you're using. In our facilities at TNO, we are doing pilot production on 1 square meter window. So we have industrial machinery and industrial washing machine, a roll coater, and some drying furnaces to scale up the technology from lab scale to 1 square meter size as in pilot scale. And this is something that we have optimized in the past to also have really large demonstrators, where you can also see one here in the exhibition. The next thing what we also have been doing and are still continuing is real-life testing. So we installed some of these windows in a test facility in Eindhoven, where we monitored the performance of the window in combination to the temperature of the glass, because the material switches its properties based on the external glass temperature. And here, the first investigation that we were doing, we're looking, okay, when does the material transition, and at what glass temperature and at what outside temperature? And what we saw there is that actually the glass temperature can be significantly higher than the outside temperature, which means that in the beginning, it looked like then, especially in spring and in autumn, there were some days where the glass temperature was already significantly hotter than the outside temperature, and the material transitioned, even though we didn't want to have that. So we used actually this monitoring to optimize our material, so that it's actually now perfectly optimized for the climate region in the Netherlands and in the Benelux. And now the second optimized version we installed again to monitor it again and look at the performance. The next thing what we are doing still this year, in the third quarter, we will install some of these windows here in an office building, where we will also monitor people working in that office, and together with the University of Maastricht also look at the comfort and the quality aspect for the people working in that office in comparison to a reference office. And we will also install some of these windows by the end of the year in these kind of modular cube homes in the Netherlands, in Herlin, for demonstration purposes. Now you're thinking, okay, well, what is the impact of these kind of smart windows on the energy efficiency and on comfort levels for humans? And here we did some building energy simulations where we compared the smart window to the regular low E-coated windows. And here we can see that actually we can have large energy savings as a combination of reduced heating and cooling consumption in the Netherlands. And this can also lead then to significant cost savings for homeowners. The cost savings are to a large extent based on reduced cooling demand. In the Netherlands, we don't have so much air conditioning in residential buildings. But even then, you see that you have a significant impact by reducing the overall temperature in houses in summer. So you have actually the increased comfort effect when you're using the smart window. I said we developed this technology in the last 6 to 7 years, and now we are actually at the point where we are in process of bringing the technology to the market. So we are establishing a spin-out. Here you can see the CEO of the future spin-out, Sven. He's also here with us. And we are currently working on the scale-up of our coating formulation, which was quite successful, so that now we can produce enough material for industrial trials, where we also did the first trials on industrial roll coaters with some partners, where we coated our thermochromic coating up to DLF glass sizes. And later this year, we also have planned some demo production where we will again coat a number of DLF glasses with our new material, and where we will produce demonstrator windows. And then we are also ready for demonstration projects with building companies to install our window. The spin-out, as said, is currently being established, so that by the end of the year, the plan is that the spin-out will go live. One thing that I now didn't have time to really pick up on in this presentation is the design for circularity aspect, but that's also something that we're looking into to see that we're now learning a lot from looking to recycle existing glass, and we know that there are a lot of challenges. And the question is, for new glass, what can you actually do to make it easier recyclable? I already mentioned that there are ideas about coatings to prevent scratches, to prevent glass corrosion. But this morning we also heard about laminated glass. So design for recycling in laminated glass, how can we more easier delaminate glass without the necessity to break it? So these are also things that we're working on at the moment. And if you're interested in that, please feel free also to stop by at our booth. Here we are at the stand C3, where you can see our smart window demonstrator, and very happy to discuss all these topics.
Thank you very much.
Thank you.